Hi there guys, back to electricity, and we're looking at circuits today. We've already looked at electricity and seen that electricity is really just the movement of electrons, which are these little parts of energy that buzz around an atom. And today we're going to look at how we control that electricity, and we usually control electricity with circuits. We like to move electricity through circuits, and there's a picture of a circuit there for you. Alright, let's have a look at the next page. Okay, on this page you can see we've got, okay, here's our circuit. You can see it's a standard electric circuit. It's got the battery, the wire, the bulb and the switch is closed so the electricity can go around. Let's have a close look at the battery. I think the battery is pretty interesting. I wonder if you've noticed there's a negative sign on the battery and a positive sign. Just have a look at that now. See if you can work out what that means. Okay, I wonder if you had to think about that. Right, what the negative and the positive on the battery means is, on the negative side of the battery there's usually lots of little electrons. Now they've been generated by a chemical reaction in the battery, so let's draw those in. Okay, and so there you are. I've drawn lots of little, four little negative electrons. There's probably more like 4 million there, but I could only fit 4. And on the positive side, there's actually these positive pieces of energy, which are called protons. Now let's draw those in. Okay, there they are. And so now on the left-hand side of the battery, you've got your surplus of electrons. Remember, they've got a negative charge. And on the right-hand side of the battery, you've got all your protons, and they've got a positive charge. Now, I wonder if you're ready for a true fact. Here comes the true fact. Are you ready? Okay guys, this is one of those things about science you just need to know. Electrons are attracted to protons. They're attracted by magnetism. Electrons see a proton, they just want to go to it. Okay? Or, the same way of saying it is a negative charge is attracted to a positive charge, and that's because electrons are negative and protons are positive. Let's draw a little picture. Okay, there you go. There's your electron with its negative symbol. There's your proton with its positive symbol. The electron will want to go towards the proton, no doubt. Negative is attracted to positive, and that's why we have things like static electricity, and your hair will stick to a balloon if you rub the balloon enough. What you're actually doing... Okay, what's happening in this picture is the lady has given the balloon a good rub on a shirt or the carpet or the like, and it's actually built up a negative charge in the balloon, right? And the hair already had a positive charge, and so what's happening is all the electrons in the balloon are sticking to the protons in the hair, and that's how you get magnetism. All right, negative is attracted to positive. All right, but let's get back to a circuit. Okay, here's our classic circuit with a full battery. The battery's got full of electrons at one end and it's got plenty of protons at the other. I wonder if you can work out what the electrons are going to want to do. Go on, you don't have to be Einstein. You know electrons are attracted to protons. What are the electrons going to do? Okay, I hope you worked out. They're going to go round the circuit, all the way around the circuit, through the light bulb, of course lighting up the light bulb on the way through because they're energy, okay? And they're going to head towards these protons. Let's keep drawing the path of the electron. Alright, look at them go there. All those electrons moving from their side on the left-hand side of the battery to the protons on the right, because negative is attracted to positive. There it is. Remember, electrons are attracted to protons, so they're all moving through the circuit to the other protons, or to the protons. Okay, and there's just a simpler picture of what's going on. Now, the very clever ones among you might be asking this. Why don't the electrons just jump over the battery? Why don't they just go from here to there? It's a great question, but there's a very good reason. In the middle of the battery, guys, right here in the middle of the battery, there is something that we call a... Okay, in the middle of a battery is an electrolyte, and it will stop the electrons from going over. It will not conduct the electrons, okay? It splits off the electrons from the protons, so the electrons have got to go the long way. They can't just jump over. Look, they might try to get over there, believe me, they want to, but they can't get past the electrolyte, okay? It won't conduct them. But the wire will conduct themselves. They'll just go the long way around, lighting up the light bulb as they go through it, and they'll come to meet their best of friends, the protons there that they love so much they are very attracted to. Alright guys, that's an electric circuit, and that's how it basically works. Any questions?